if the quadratic function we are given is of the form ax squared plus bx plus c, often called the standard form, find the vertex by using the vertex formula. Negative b over 2a. Oftentimes you see this written as x equals negative b over 2a. And we have the point f of negative b over 2a. I'm going to write this as y equals f of negative b over 2a. And you can also see this actually as h equals this and k equals this. So we'll evaluate, once we find our h value using negative b over 2a, we will evaluate, let's go ahead and write this, the function at the value h to find the k. Find x with the formula, then plug into the equation to find y. Determine if it opens upward or downward, the parabola. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. Find any x-intercepts by solving f of x equals 0. The function's real zeros are the x-intercepts. Find the y-intercept by computing f of 0, and then plot the intercepts, the vertex, and additional points as necessary. Connect them with a smooth curve that's shaped like a bowl or an inverted bowl. Let's look at a couple of examples. Sketch the graph of this function below. G of x equals x squared minus 2x minus 2. Well, that is of the form ax squared plus bx plus c, where a equals 1, b equals minus 2, and c is also minus 2. So to find the vertex, first we will find h. Okay, I'll write these formulas up here. H equals negative b over 2a, and k is f evaluated at h. Let's use the space down here. H equals negative b, well that's negative, negative 2, note the two negative signs, divided by 2 times 1. So that would be 2, positive 2 divided by positive 2, or 1. So my vertex is 1 comma something. I'm going to evaluate my function at 1 to find k. So k equals 1 squared minus 2 times 1 minus 2, which is 1 minus 2 minus 2. Let's see, that would be negative 3. Negative 3. So our vertex is the point 1, negative 3. Let's go ahead and put that point on my graph. The axis of symmetry is at x equals 1 based off of my vertex. To tell if it's a maximum or minimum, I have to notice that my a value is 1. A value is 1, so this opens up. So this appears to be a minimum. The value of that minimum is negative 3. Y equals negative 3 because that is the lowest point that our graph gets to. That also tells me my range, so I'm going to go ahead and answer that. This begins at negative 3 and goes up to positive infinity. Because this is still a polynomial, we can tell that in this form. The domain is minus infinity to infinity. And the last thing we need to find is our y-intercept. Let's add a couple of points on here, and we actually see the y-intercept from the points I've graphed, or that I've plotted, and that is 0, negative 2. But we could always evaluate this, so we can say 0 squared, 0 squared minus 2 times 0 minus 2. 0 minus 0 minus 2 is negative 2. So there my y-intercept is 0, negative 2. Let's look at one more example. Sketch the graph of this function. G of x equals negative 2x squared minus 4x plus 3. Now, let's identify a, b, and c. A for this function is negative 2, b is negative 4, and c is positive 3. So h is negative b over 2a. That would be negative, negative 4 divided by 2 times negative 2. So that would be positive 4 divided by negative 4, or negative 1. So my vertex is negative 1, comma, something. Now, let's find that. K is equal to f of whatever my h value is. So negative 2 times negative 1 squared minus 4 times negative 1 plus 3. The first term would be negative 1 squared is positive 1. So this would be negative 2 plus 4, because we have negative 4 times negative 1, plus 3. So that would be 5. So my vertex is the point negative 1, 5. Go ahead and plot that. Negative 1, positive 5. My a value is negative 2, which means this opens downward. And it's stretched by a factor of 2, so I find the point 0, 3, and negative 2, 3. And I have another point at negative 3, and 1, negative 3. Since I know how it is stretched. Knowing function transformations helps a lot. So my axis of symmetry is x equals negative 1. This appears to be a maximum because it opens down. And the maximum value is 5. Y equals 5 because that is the y-coordinate of our vertex. The y-intercept is 0, 3. And if we were to evaluate this function at 0 here, we get positive 3. Because it's a polynomial, my domain is minus infinity to infinity, and the range, we have a highest point of 5, so our range is minus infinity to 5, including that 5 with a bracket.